graphic analyses of EEG effects or ERP effects in particular. And hopefully you guys had a chance to visit with some of the files that I posted to our Box.com account. They included some Excel sheets that are essentially calculator files that will calculate what we'll talk about is the range normalization procedure in order to do the topographic analysis. And they also include essentially a step-by-step instruction sheet in Microsoft Word. So all that stuff is there. I'll try to follow it in roughly close correspondence. But the idea about doing topographic analyses and some of the merits of them are covered in a handful of different publications. I refer to it in my 2015 paper. There's a section in the results it's called Topographic Analyses, and there's an introductory paragraph there that provides some really good references of support for why these analyses are useful and indeed what they're showing us. In particular, Rugg and Coles, Ed Wilding has a paper in 2006 that described the process of range normalization as well, and some good conversation in the literature with that, with Mark Kudis's lab, that had a couple complementary papers back and forth there in 2006. So a lot of background reading there. In general, what we're going to do is we're going to take our normal microvolt ERP effects. Now remember, an effect is a subtraction between two conditions. So let's say old minus new is going to give us the memory effect. And anywhere where there's a difference in that subtraction between the two ERP conditions is going to be essentially considered a difference due to memory, right? This is basically Donder's subtraction logic, canonically in the field. And so we have an ERP effect that we can plot that difference wave and see the topography of. And the question of essence here is, does the particular spatial topography of an ERP effect differ from where in the scout a different spatial topography is essentially for a different comparison effect. So we talked about this last class in the context of comparing the scout topography of a conscious explicit memory effect compared to the scout topography of a conscious implicit memory effect. And particularly, we use the analogy of sort of being a defense attorney in like a robbery case. What you want to do is have an airtight alibi to get your client off the hook and say, this guy cannot have been the robber because he was in a different place at the same time. Okay? So this is what we were trying to do with the comparison between explicit and implicit memory effects at the scout. Okay? We were trying to show that during the same time, in this case, say 400 to 600 milliseconds, that they were in a different spatial topography. Okay? Now, in order to do that, the first thing we need to do ultimately becomes extract the values, but really, particularly, the first substantial thing we're going to do is basically what's called range normalize those values. So instead of having, basically you're setting mountains and hills onto the same scale. You're basically normalizing that process. That's what our Excel sheets are going to calculate for us. I've set that up for us ahead of time, and I'll talk about the process we're going about that. And basically what's going to happen is we'll normalize those values such that we can then compare the effects of spatial topography. Okay, so just because one effect might be bigger, spreading out all across the scalp, doesn't mean that it's not actually located, sort of spatially localized within a particular region that can then be compared across a smaller effect that might just have less spread across the scalp. Does that make sense? Okay, let's take a look at some of the processes for how that's going to happen. So here we are. I'm in my EEG Lab folder, particularly downloaded the folder that we had Box.com for topographic analysis, range normalization procedures. First thing that we're going to do, of course, is open EEG Lab, so I'll type EEG Lab. We see that happen there. Okay, so now we bring up EEG Lab GUI, and what we need to do is basically extract these simple statistics. So, for example, what I will do is do our ERP measurement tool within the ERP Lab menu. So in this case, I'm actually going to remove all these ERP files. I'm going to load a handful of ERP sets, and that's going to come from our, let's see, where do we have those effects? You guys actually have more of these files probably available than I do at this point. Results. I guess I will just use a handful of our samples. So we'll do 4 through 10. we'll do is do our normal measurements, in this case our average amplitude between two latencies. Okay, our bin in this case, I'm going to say is 188, which happens for this experiment to be the subtraction between conscious reports of essentially high confidence with 5 responses in old new recognition, and the lower confidence 4 responses in old new recognition. Okay, our channels are going to be 1 through 32, and that's important because we need all of the electrode channels in order to get a proper value of what the normalized version of each electrode's measurement is. Okay, and we'll see what we mean by that. So, let's see here. We'll do that. Actually, what I might try to do is add some more group sets of things. I'd love to get to 25. Let me see. This is. Let's see if I can find other things. Okay, that's probably what I'll do here, actually. Yeah, I will do 3. So we'll have a much cleaner version of seeing how our effects can operate. So let's say that. And so we have all that output. Measurement window, we'll put 400 to 600 milliseconds because that was the time point that we were interested in. And then we want to save this file. And so what I'll do is I'll save it as a new thing. And we'll put it in our, I'll just save it in this typographic folder, so I'll just call it raw amplitude output. And we will run that. Continue, name that group. Yes. So hopefully this ought to work. And then we'll calculate these statistical values. And then we're going to work with them. In particular, we'll open up some of our sheets, worksheets, that were here in our typographic folder. So, let's see. In our instruction sheets, that's basically what we started off covering. While that's thinking, I'll walk through here. This is an introduction to the idea of understanding first the conceptual basis of what a topographic analysis is and what range normalization is. It refers you to the idea that it's addressing the spatial topography of an effect. Remember, an effect is a subtraction between two conditions. And so, for example, source correct minus source incorrect. So this is basically an introductory primer, and it gives you a link to that results section from the paper that we referred to that provides a much deeper coverage of the concept and the approach of topographic analysis. Okay, so we opened the GLab, we extracted our statistical measurements, so we got that now. This is sample output code for how you can do that. You guys know how to derive those codes by typing ERPH in and getting something similar. And then what we'll do next is we'll open the Excel file of our range normalization template. Okay, so let's make sure that this is gotten done running. It looks like it has. So we're going to open that template. Now let's say I'm going to do it for 25 subjects. I'm pretty sure that's the number of people that we have. We'll sort that out. Okay, so this is our template. All right, there's a lot of stuff here, and I'll zoom around and I'll show you a bunch of stuff, but there's really only two things that matter. Okay, I've done all the calculations for you, and I've set all the math up. All you have to do is copy the stats that we just extracted and paste them in here. Once you paste that in here, all these numbers will be filled in because they're calculated. They're calculation formula that are typed into every one. Okay, so that's what we have in this instruction here. Okay, if you zoom in, that's what these two things say. So there's only two things you really need to do. It's basically one, paste in the raw voltage amplitudes. Tells you exactly where to paste it into. Okay, in this case, basically it's going to be down here. And then it's going to tell you that normalized values are automatically calculated. So let's do exactly what we're talking about here. I'll give you a quick little overview of this sheet. Okay, so if we zoom out, we can see there's actually lots of stuff happening here. Okay, so every one of these rows is for one of our 25 subjects. Every one of these columns is for one of our 32 electrode channels. Okay, and so what's going to happen is we have a handful of calculations that are done in the steps to normalize basically this scout map. And so it's going to basically bounce between here, 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 and here. So you basically take the average, you have to basically then normalize that to the minimum and the maximum that's calculated for each channel, for each subject. And it basically comes down into, this is basically the other part that matters. I said there's two things that matter. You paste it in here. This is our output. So these three are just there as calculators. You don't have to look at them. You don't have to do jack. You paste it here, and you find what the output is here. And that's it. Okay, and I'll zoom in and we'll talk about exactly that in more detail. So, let's see. Okay, let's open up our stat output file, which here is this raw output. So, what this is grab all this is that difference wave. So it tells us it's bin 188, the subtraction between old 5 and old 4 responses at electrode site FP1, at electrode site AF3, at electrode site F7, F3, FC1, yada, yada, yada. Okay? So, for each of our subjects. All right? Now, I think I have our spreadsheet set up for 25 subjects, and this right now is set up for 23. So what I'm going to do, I'm going to create some pseudo subjects. I'll copy 2 of those there. We'll paste them down there. It's perfectly fine for illustrative purposes at this point. So all you do is you highlight all this raw data across our 32 channels, just like that. Control C to copy, and then we're going to come back to our calculator sheet, which is here. Okay. We paste it right where that arrow goes. Cell C12. You can right click and paste. Okay. Now notice that when we did that, all those cells here become numbers. What they are don't matter for the purposes here because they're not the part that matter to us. We see that everything else became numeric as well. We've got the minimum of the average, the maximum of the average, and of course the subtraction of the maximum and minimum. These are some important values for the calculation sheet. But like I said, all that matters for using this is this highlighted yellow table. These are the range normalized values now. And you'll note that you can verify that because this is the minimum of all our scalp average is 0, and the maximum has become 1. So what it shows is that we've actually normalized the range. Okay? So everything on the scalp, no matter there's a huge effect or a little one, right? We could have had big 3.5 microvolt things or smaller ones. Now it's all on a scale of 0 to 1. Yes, Henry?
One of the averages, I think it's OT or O2, it's negative. Negative 3.3 e to the 17.
Yeah. Well, that is still basically 0. I mean, it's basically to the negative 17. That's functionally 0. So, anyways, this is the basic idea there. And so, I mean, this is just it's basically 0. So, and these, of course, are the average of each of these columns. So this is our range normalized thing for all of our subjects, for all of their electrode sets, for this effect. So then what you'll do next, and this is shown here on our instruction sheet. Okay, so we've already done, open the range normalization, open the text of the stat output, highlight select, yes, we got those. Paste that information into C12, we just did that. Okay, now it shows how the data table on the bottom left, most part of the worksheet is the range normalized of each score. We just talked about that, it's highlighted in yellow. You just saw that. Okay, now what we'll do is we will highlight the data in the yellow table, that is our range normalized output. We're going to copy that too, and we're going to basically put that in a new sheet. So what we can do is we can take all of this, just like that, So first of all, see how if I click in this box, right, this is still a formula, AH63 divided by BO63. So this is not just a number, this is a formula. So what we want to do is make it more of a number. Escape out of there. We're going to create another sheet here. Actually, we'll get this one side. Copy. You can add Control N for new. And what you can do is right click, paste special values. So that's what we're looking at here. You have different options of what you can paste. The formula, transpose, the format. We want to paste values. What this is it's just pasting the numbers that we've now calculated, no longer the actual calculated formula. If we did that, you'd have a bunch of goofy errors in here. So now we're actually just using the data. Okay? Paste special value. So now we have all that stuff. Okay? And that's kind of what we talk about at this point. Okay? In the new worksheet for paste values and do that. We want to save it. Okay? First of all, we can come back and save our template here, but you don't want to save it as the template, so you want to save it as, and of course, you don't want to say template for range normalization. You're going to say, the sample size, N25, what your bin was, so, or your condition. So in this case, it was bin 188, put your latency in there, 400 to 600 milliseconds. Again, we're labeling the file so we can go back and get it. Because you want to keep your template blank, so you can continually reuse it for other people. Because what you'll do, right, is now that we have the data of what we want here, which is our range normalized values, this will form the basis. And you can take that base. So you want to do 3 different electrode sites in 3 different quadrants. So you'll take those, you can take those 3 electrode sites, let's say C3, CP5, or whatever. You can insert a couple extra rows here, and you can say this would be your average of left parietal equals mean, or average, of, grab those 3 suckers. You can do that if you need to, or you can run an ANOVA with those 3 levels of that left parietal thing. So now you can work with the data statistically of the mean values and run your 2x2 ANOVAs or whatever it is that you need, which is described a little bit. We don't have a lot of time left in class, but that statistical process is described now in the bottom part of our instruction. So the first thing we want to do is do the exact same thing of what we just did, but now for that other effect that you want to compare it to. So let's just say we did that for the bin 188, the explicit memory. Now you would go back, do the whole thing, extract new values for the implicit memory effect in this particular example, or whatever other effect you have of interest. Create a second sheet where you have these same values output. So now you have the range normalized values for the implicit topography, range normalized values for the explicit topography. Okay? And then once you have these 2 Excel files that's noted here, now you're ready for stats. That's point 9 in the instruction sheet. All right? And so basically I walk through a couple examples of how to do that with either an ANOVA and how to organize some of those quadrants. So just frontal versus posterior effects. Or you could slice up the posterior area to left posterior, mid butt posterior, or right posterior type of thing. And it shows you a couple basic ways to do that. There's an online free calculator for ANOVAs here. You can use R if you're statistically inclined and have experience with that free software. You can use SPSS, which I think a lot of campus computers have too. Vaster Stats works perfectly well as well, and it's free. But that's the basic idea of how to do that. And then you just run your same stat on these topographic or these range normalized values, and that will give you the answer to whether or not 2 different ERP effects differ in their scout topographies. And it will not have any bearing on whether or not they're the same or different on the magnitude or the size of those effects, just in their spatial distribution. Because you've normalized the size to be equivalent on the same scale of 0 to 1, and that comprises the process of doing a topographic analysis. And hopefully, it really is as simple as extract the stats, which you guys are experts of now, highlight, copy, paste. Template does all the thinking for you. Highlight those, copy, paste this values, run stats. And that's it. So hopefully that helps to clarify that. And I'll try to make a screencast of it, or maybe you guys can. And next time we meet, I'll try to also cover some stuff about the implicit memory procedure, which is a little bit more complicated than that. And don't forget that next class we will also have a guest presenter about graph theoretical analysis. So does anybody have the Mike Cohen book? Did anybody buy that? A couple people did? Okay, so if you want, you can share the chapters on graph theoretical analysis with your classmates. If not, I'll try to do that as well. So it's best to come prepared for that lecture, so you know a little bit about what she's talking about. But you know, that's my suggestion. Other questions? Time's pretty much wrapped up, so thanks for your